Okay, geometries, this is Mr. Bloom. This is Geo Chapter 2 practice test. Now, use inductive reasoning to describe each pattern and find the next two terms of each sequence. Well, I'm going 1, a third, a ninth, a 27th, a 181st. I'm multiplying by a third each time. So that's what I'm doing, or dividing by a third, or by 3. Multiplying by a third or dividing by 3. Either way, the next two are 1 243rd and 1 729th. This next one, going down by zero point 0.6. So I'm subtracting it. So the next two are 1.5 and 0.9. Now find a counterexample for each statement. An apple is a red fruit is the first one. This is not an if-then form. Counterexamples have to fulfill the hypothesis, and then the conclusion must be different. So if we look at the original in if-then form, if it is an apple, then it is a red fruit. So let's look at this. An apple is a red fruit. If it is an apple, then it is a red fruit. Well, I have to find an apple that happens not to be red for my counterexample. So an apple that is green or yellow or multicolored, like a one of those nice crunchy fall ones. What's that called? Oh, you'll know. Anyways, so if number 4, if a parallelogram has 4 congruent sides, then it is a square. So for a counterexample, I must fulfill the hypothesis. A parallelogram that has 4 congruent sides, but it can't be a square. Well, that would be a rhombus. A rhombus is a parallelogram with 4 equal sides. That's not a square. Now, in 5, write the converse, the inverse, and contrapositive of each true statement. Okay, determine the truth value of each. So I have my original conditional. If a polygon is a triangle, then it has exactly 3 sides. The original is P implies Q. The converse switches P and Q, so it's Q implies P. So if a polygon has exactly 3 sides, then it is a triangle. Okay, now in this particular case, when I'm looking at this, I'm going, well, just polygon 3 sides, that's true. Okay, now inverse. An inverse negates the hypothesis and negates the conclusion of the original statement. So if a polygon is not a triangle, then it does not have exactly 3 sides. Okay, if it's not a triangle, it won't have exactly 3 sides. So that is also true. Now, a contrapositive. A contrapositive negates and switches. So it's a converse inverse. So I'm going to go, if a polygon does not have exactly 3 sides, then it is not a triangle. Okay, and that is also true. One of the things that helped me out doing this is I know that the original, and this original, if the original statement and its contrapositive must have the same truth value. The converse and inverse must also have the same truth value. It so happens in this particular one, they are all true. So let's go on to our next one and practice these. If Jared is in 11th grade, then Jared is in high school. That's my original statement. The converse is when I switch this and this. So if Jared is in high school, then Jared is in 11th grade. Okay. If Jared is in high school, then he is in 11th grade. That's not necessarily true because he could be in high school and be a sophomore or a senior. So that is not true all the time. So it's false. So the converse or the inverse would be if Jared is not in 11th grade, then Jared is not in high school. Jared is not in 11th grade, then Jared is not in high school. Well, again, this is false because he could be a sophomore and be in high school. He doesn't have to be in 11th grade. Okay, but he's not in 11th grade. He could be 12th grade, 9th grade, or 10th grade and still be in the high school. Now, contrapositive. If I'm looking at the contrapositive, it takes the conclusion and negates it and puts it in the position, in the front position, and the hypothesis negates and puts it in the back position. So if Jared is not in high school, then Jared is not in 11th grade. Okay, he's not in high school, he's not in 11th grade. That would happen to be true. Okay, and again, The original, if Jared's in the 11th grade, then he is in high school, is true. The contrapositive is true, and the converse and inverse are both false. So the original and the contrapositive have the same truth value, and the converse and the inverse have the same truth value. Looking on, is each statement below a good definition? If not, explain. So good definitions have a forward and reverse value. So the original if-then statement and its converse both make sense. Okay, so here a square has exactly 4 right angles. If a shape is a square, then it has exactly 4 right angles. And then you have to consider if a shape has 4 right angles, then it is a square. So these are my 2 statements. Now, you got to keep in mind, if a shape is a square, then it has exactly 4 right angles. Well, it works. If a shape has exactly 4 right angles, then it is a square. Well, that's not necessarily true. That's a rectangle. A shape has 4 right angles and 4 equal sides, then it is a square. So in this particular case, they're asking, is each statement below good definition? In this one, it is not. This is not a good definition. Okay, so no, and my example and explain is a rectangle can fit the second one. So we are missing some information for 7. In 8, supplementary angles are 2 angles whose sum is 180. Written in if-then form, if 2 angles are supplementary angles, then their sum is 180. Or I could see the converse. If 2 angles have a sum of 180 degrees, then they are supplementary angles. Well, this is true. Okay, so this is a true statement, and so this works. So this is a really nice definition in number 8. In number 9, horses are animals with 4 legs. Well, they're saying that if it's an animal with 4 legs, then it is a horse, because horses are animals with 4 legs. So animals with 4 legs must be horses. And if it's an animal with 4 legs, then it's a horse. Well, if I look at this, if it is a horse, then it's an animal with 4 legs. Well, this isn't a good statement because animals with 4 legs could be dogs. So a dog could be an animal with 4 legs, and I put that answer in here someplace and I misplaced it. So this is not. So this is a no. Dogs are animals with 4 legs. And I really did. There it is. No, dogs are animals with 4 legs. Whew, thought for a minute there I didn't have it. Okay, let's look on page 2. Looking at 10, use the law of detachment and the law of syllogism to make the possible conclusions. Write not possible if you cannot make any conclusion. If you want to get a driver's license, you must take a driver's education course. John wants to get a driver's license. So when we're doing this first part, for this be law of detachment, okay, John wants to get a driver's license, must fulfill the hypothesis, and we have. If you want to get a driver's license, John wants to get a driver's license, then you must take a driver's education course. So this is the logical conclusion that John must do. John must take a driver's education course. And 11, if you miss more than 5 days of mathematics class, then you will not get a good grade. If you do not get a good grade in mathematics, then you will not be on the honor roll. Okay, if you miss more than 5 days in math class, then you will not get a good grade. All right, my linker is not a good grade, so I've got a good grade. Okay, those are linking together. If you miss more than 5 days of mathematics class, then you will not be on the honor roll. Okay, if you miss more than 5 days of mathematics class, then you will not be on the honor. Remember that linker. The linker is important, and that's the law of syllogism. So now, in 12, if you buy the newest video game, you will not have enough money for lunch. And remember, this is an implied then. It's right there. If you buy the newest video game, then you will not have enough money for lunch. If you do not have enough money for lunch, then you will not eat lunch. So I have a linker, you will not have enough money for lunch. You do not have enough money to eat lunch. So we don't have enough money, okay? So if you buy the newest video game, then you will not eat lunch, okay? And 13, Marla likes milk. She also likes orange juice. And here's a true statement. If Marla chooses milk to drink, she cannot have orange juice. And remember, this is going to be the idea of our connection of the law of detachment. If Marla chooses milk to drink, she cannot have orange juice. Well, Marla likes milk, okay? And Marla chooses milk to drink, okay? Now, she cannot have orange juice, and she also likes orange juice, but Marla chooses milk to drink, so we're thinking Marla cannot have orange juice. 14, 15, 16, 17, 18 are all property oriented. And these happen to all be properties of equality until I get to this one. Okay, and because that one's a property of congruence. I'm just going to make sure that my eyes are not deceiving me and look at the original. And yes, that's property of congruence. So now, if measure of angle ABC equals the measure of angle DEF, and the measure of angle DEF equals the measure of angle ABC, that's symmetric property of equality. 15, AB equals CD. Now this is the length AB equals the length CD, and the length CD equals the length EF. Well, if I can say AB is equal to EF, I'm using transitive property of equality. In 16, I have this original statement, x plus 7 equals 5, and then I'm going to subtract 7 from both sides. Well, that's subtraction property of equality. In 17, x equals y. If x is 18, then y is equal to 18. Well, that is substitution property of equality. And my last one here, I've got angle A is congruent to angle A, okay? And that should be not of equality, okay, but it should be of congruence. And the reason why it's congruence is because of this sign right there. And I'm sorry I missed that earlier, but I have reneged and said, hey, it's of congruence. So this is reflexive property of congruence. And our next one, I am using in problem 19, vertical angle theorem. 3x minus 63 is equal to x plus 37 because vertical angles are congruent and therefore equal by definition of congruence. I'm just going to double check to make sure that's what I'm supposed to do. Okay, now I'm going to subtract x and I have 2x minus 63 equals 37. I'm going to add 63 and find 2x equals 100 and divide, and I find that x is 50. They only ask me to find what x is, so I'm good to go. Now in 20, I have this little thing here that says this is perpendicular to this. Perpendicular segments, razor lines, make right angles. Right angles are 90 degrees. So by angle addition, I know 4x plus 5x is going to be equal to 90 as well. So I've got this going on, 4x plus 5x equals 90. So combining like terms, I have 9x equal 90, and dividing by 9, I have x equal 10. So we're doing okay so far. Okay, going on to our next page. Write the two conditional statements that make up the biconditional. Doug watches football if and only if the Vikings are playing. Now remember the two conditionals, the forward sense, the original conditional, and the reverse sense, the converse of the original conditional. So if Doug watches football, then the Vikings are playing. Okay, if Doug watches football, then the Vikings are playing. The reverse of that, or the converse, remember this was the forward sense, okay, of a biconditional, would be if the Vikings are playing, then Doug watches football. Now in 22, I have a reasoning thing. And use the diagram at right to complete the proof that the measure of angle ACD is 130 degrees by filling in the missing steps. Now, if I'm looking at this, I have the measure of ACB. Oh, by the way, your B is not there, and BCE, and your E is very, very faint. So why don't you just put those B's and E's in. Now, if I have that, I've got this going in my picture, but that's a linear pair. And that linear pair is equal to 180 degrees because linear pairs are supplementary. So I can say that with linear pair postulate. I can now plug in for ACB 5x. And where I see BCE, I can plug in 9x plus 40 by substitution, property of equality. Now, I can combine like terms. 9x plus 5x is 14x plus 40 equals 180. It's combining like terms. And what happened between this step and this step? I'm subtracting 40 on both sides. So a subtraction property of equality. And go from 14x equal 140 to x equal 10, I must have divided, and I've got division property of equality. And now we're just substituting by checking our value. Measure of angle BCE is equal 9 times 10 because we're plugging it in. Okay, 9 times 10 is plus 40 is 130. Now they're saying that this is a measure, and they're saying that this that angle BCE is congruent to ACD. Let's check this out. BCE is congruent to ACD. Well, these are congruent because they're vertical angles. I know those are vertical angles, VAT, vertical angle theorem. Now, when I do this to go from here, congruence to measure being equal, it's a definition of congruence. I could say definition of congruent angles, but then I'm going to use substitution because we're going to find out that ACD is equal to 130 degrees. And I already know that BCE is equal to 130, so I can substitute and find that out. So I was able to find out that the measure of angle ACD is 130, but more importantly, I was able to use linear pair postulate, substitution property, subtraction property, vertical angle theorems, and definition of congruence in the correct way. Now, looking at 23, what is the inductive reasoning? It is a type of reasoning that reaches conclusions based on a pattern of specific examples or past events. What is deductive reasoning? That is a process of reasoning logically from given facts to a conclusion. So deductive is based on facts, inductive is based on patterns. Now, in 25, identify the hypothesis and conclusion of the statement below. Now, if signals that the hypothesis follows. I have no leftovers in my fridge. So that's my hypothesis, that is P. Then signals my conclusion follows. I will have peanut butter and jelly for lunch. Okay, and remember, the hypothesis does not include if, the conclusion does not include then. They are standalone statements without if and without then. Now, our page 3. Determine whether the conditional and its converse are both true. If both are true, combine them as biconditional. If either is false, give a counterexample. If a coin is a penny, then it is worth 1 cent. Well, that is true. If a coin is worth 1 cent, then it is a penny, and we're assuming we're defining American money. So when we do this, we have both of these statements true. So now I can write a true biconditional where I drop if, I drop the then of the original one, and say a coin is a penny if and only if it is worth 1 cent. So now in 27, I have a segment addition property setup. This plus this is equal to the total, but this is interesting. This says given. Look at xy is equal to yz. Y must be the midpoint. So these are equal. So we can set them equal. By substitution, we have these set in. And now, what happened between this step and this step? Looks like the 6 is gone and the 8 was adjusted. What happened? Oh, we subtracted. We got subtraction property of equality. And then I go from this step to this step. What happened? What changed? Well, I subtracted 5 from both sides. Well, subtraction property of equality. What happened from this step to this step? The 2's are gone. 2 is gone, the 12 divided. Oh, division property of equality. So these are our steps as we go through, and these are statements, and these are reasons for those statements. Now remember, this was because y is the midpoint. I can do this. Let's do one where I have segment addition postulate. Segment addition postulate states AC plus CB is equal to AB. Gosh, I got it right here. That's segment addition postulate. I know that AB is 50 because they gave it to me, and I say that right there, but segment addition properties, it shouldn't be property. It should be postulate. Somebody has to change that. Ta-da! Look at that, segment addition postulate. Okay, segment addition postulate is from chapter 1, AC plus CB, they have to share a common point. They're on the same segment. They can make up the pieces of AB. Now, by substitution, I got 2x minus 2 in for AC, 4 times x plus 1 in for CB. That's what I'm doing there. And I put in 50 for AB. Now, I do this, so I'm getting rid of the parentheses by distributive property. And then I combine like terms, and I go from this one to this one by subtraction property of equality, and then I have division property of equality. My last ones on your notes in 2-2, if you look at them, okay, 2-2, you have right at the top that Venn diagram. Open up your notes to 2-2. Over on the side, you have the Venn diagram, and you have P inside, Q on the outside. So if P, then Q. If a language is Italian, then it is a Romansh language. Okay? And that's how we write a conditional statement with each Venn diagram illustrated. Number 30. If P, then Q. If a number is 29, then it is a prime number. And that's all we've got, ladies and gentlemen. That's where we're going. If you have questions, you got to ask Mr. Bloom, Mr. Monahan, or Miss Scotia what's going on, because we are here to help you out. Have yourselves a wonderful day, boys and girls.